Hi guys. Yes, today we're going to be talking about fetal circulation. Before I proceed, don't forget to like, subscribe, and share this video, and turn on your notification bells to get notified each time a new video is dropped. Now, back to it. Fetal circulation is just basically how the fetus receive nutrients via blood from the mother, right? So it's just that way, and oxygenated blood reached the fetus through the umbilical vein, right? Umbilical vein carries oxygenated blood to the fetus, and this oxygenated blood, the oxygen is used up by the fetus and finally becomes deoxygenated, and again the oxygenated blood is carried away from the fetus to the mother by the umbilical artery, right? So this is just basically the two arteries involved. However, the purpose of fetal circulation is not just because there is transportation of oxygenated blood via the umbilical vein and there is removal of deoxygenated blood via the umbilical artery from the fetus. However, because this blood is already oxygenated and waste free, right? It does not need to go through the liver or go through the lungs. The liver for detoxification and the lungs for oxygenation. So that is why there are certain bypasses in the fetal life that are not present in adult life, right? So these bypasses, we have the liver and we have the lungs. So for the liver, we have ductus venosum, venosum or venosus. Then for the lungs, we have ductus arteriosus, right? Then we have the third one, which is not really oxygen, and which has nothing to do with whether detoxification or oxygenation, but it is needed, and this is the foramen ovale, which is found in the heart. In the heart. Now, how do these things work? This is our placenta, right? This is our placenta. So in the placenta, we have our, and just so we know, we have only one umbilical vein and two umbilical arteries. So I'll be using red for artery and blue for vein. But we should know that these colors have nothing to do with whether it is oxygenated or deoxygenated, right? So because I didn't mention initially that our umbilical vein carries oxygenated blood and our umbilical artery carries deoxygenated blood. So this umbilical vein carries oxygenated blood from the placenta. So this structure here is our placenta. So this is our placenta. Now, this blood coming through the umbilical vein is already free from toxins, is free from carbon dioxide, which implies that it is free or purified and it is oxygenated. Now, this is our liver. This is our liver. Don't mind the drawing of my liver. Now, instead of this blood to go into the liver to get detoxified, remember our liver, we have the portal vein, right? Our portal vein dividing into, this is our portal vein, this is our right and left branch of portal vein. So right and left branch. Now this right here is our umbilical vein. Our umbilical vein will drain into the left branch of portal vein. But then instead of this blood to go through the left branch into the liver to get detoxified, because it is already detoxified, then we now have another shunt that will connect it directly. Don't mind my drawing, to the IVC. So this right here is our IVC. This is our IVC. From the liver, we have our portal vein. the left branch, and the right branch, right? So this is our umbilical vein draining into the portal vein. This is the portal vein, right branch, left branch. This right here is our liver, and this is our umbilical vein coming from the placenta. Now, instead of this blood to go into the liver to get detoxified, then again from the left branch of the portal vein arise a bypass, and this bypass is what we mentioned that is present in the liver. So this is our IVC. So the bypass, what it does basically is to connect the left branch of portal vein with the IVC directly. So it bypasses the liver and connects the left branch, pardon me, of portal vein to the IVC. So this right here is our ductus venosum or venosus. So this is our IVC, right? This is our IVC. Then don't forget that our IVC normally its function is to carry blood from the lower part of the body into the heart, that is deoxygenated blood. So right here we're shading blue with deoxygenated and red with oxygenated. So in the IVC we have two type of blood there. We have the oxygenated blood and we have the deoxygenated blood. The oxygenated blood coming from the umbilicus, which is oxygenated, and the deoxygenated blood coming from the lower part of the body, which is our lower limbs and the likes. That is the oxygenated blood from the baby. Then this blood somehow is not mixed. That's why I separated it. Somehow. All glory be to God. It's not mixed during fetal life. The IVC carries this blood just the way it is into the heart. So don't mind my heart. So I'll just be drawing something like this for my heart. So this is my right atrium, this is my right ventricle, my left atrium, my left ventricle. For my right atrium, we have SVC, we have IVC. For my left atrium, we have four pulmonary veins. 1, 2, 3. This is 1, this 2, this 3, and this 4. From our left atrium, our left ventricle, we have pulmonary, we have aorta, and from our right ventricle, we have pulmonary trunk. Right? So now, in this place, like I said, the blood does not mix, so it continues like that into the heart, both oxygenated and deoxygenated blood in the IVC. The blood continues without mixing. Then upon getting to the heart, this blood does not need to go through the right atrium, that's the oxygenated blood. It does not need to go through the right atrium, the right ventricle, then into the pulmonary trunk, then into the um, pulmonary circulation. So what happens basically is that there is the third shunt in this place. The third shunt, although I've not mentioned the second one, which is our ductus arteriosus. This ductus arteriosus, I've not mentioned this, but let me just go to the third shunt, which is our foramen ovale. And this third shunt basically what to do is to connect the right atrium and the left atrium together during fetal life. And this is our foramen ovale. Foramen ovale is just the opening that connects the right atrium with the left atrium during fetal life. So now this oxygenated blood is shunted directly from the IVC into the right atrium, then finally into the left atrium. And what will the left atrium do? Take it into the left ventricle, then directly into the systemic circulation. So let me number this place 1 and this place 2, this place 3, then systemic circulation 4. So that's the process in which the way or the routes in which the oxygenated blood goes from the IVC. Now you might be wondering that what happens to the oxygenated blood that is not mixed with the oxygenated blood. Well, this goes through the normal process of heart pumping, like the normal adult life. So this will enter into the right atrium. And mind you, I said we have a valve. My video of heart, derivative of 5-chambered heart, I mentioned that we have a valve. Do well to watch the video. We have a valve of IVC called eustachian valve. So it's this valve that will help to guard the movement of the oxygenated blood from the right atrium into the left atrium without allowing the oxygenated blood to go through that part. Now this deoxygenated blood will now go through the right atrium, but instead of going through the foramen ovale into the left atrium, because that way it's going to mix with the oxygenated blood, it will go directly into the left ventricle. Then from the left ventricle, from the left ventricle, this is where our third shunts now come in. From the left ventricle, our third shunts come in. Now, guess what? We have this so-called shunts that connects the pulmonary trunk with the aorta. So this third shunt that we have, this third shunt is our ductus arteriosus. I know we might be wondering that, okay, with all the whole purpose of the blood is not mixed in the IVC, then it is shunted directly into the left atria, from the right atria, then into the left ventricle, then into the systemic circulation. And then again, the oxygenated blood, we don't want it to go to the lungs because the lung is not functional during fetal life and it is deoxygenated. It needs to be oxygenated, so it needs to be carried to the placenta, right? And how can this be achieved? It has to go through the umbilical arteries, and the umbilical arteries are not direct branches from the heart. Instead, they are direct branches from the internal iliac artery, and the internal iliac artery is a branch of common iliac artery. Common iliac artery, a terminal branch of abdominal aorta. So now, for this blood to get to the abdominal aorta, it means it has to enter into the aorta, right? The ascending aorta, it must enter into the aorta basically. So this deoxygenated blood goes into the right atrium, controlled by the eustachian valve. It enters into the right ventricle. The right ventricle will carry it into the pulmonary trunk. So instead of this blood to go from the pulmonary trunk to the lungs, it is then shunted via this part, which is known as our ductus arteriosus. It is shunted into the aorta, ascending aorta. So a question or MCQ question can come that in what part of the fetus do we have mixed blood? Remember that our oxygenated blood from the left ventricle is in the aorta. Again, and our deoxygenated blood from the left ventricle is entering into the aorta. Don't mind my drawing. I just want us to take note that where the ductus arteriosus is connecting the pulmonary trunk and the arc of aorta right? It's connecting the pulmonary trunk and the arc of aorta. So it can be asked in an MCQ question that where do we have mixed blood in fetal life? So we have mixed blood. By mixed blood, I mean where oxygenated blood and deoxygenated blood, where they meet. So we have mixed blood in arc of aorta and descending aorta. Our ascending aorta is only filled with oxygenated blood. But when we get to the arc of aorta, because of the shunt from the pulmonary trunk to the arc of aorta, the oxygenated blood coming from the right ventricle will get mixed with the oxygenated blood coming from the ascending aorta. And these are the places where we have mixed blood, the arc of aorta and the descending aorta. So this blood goes down the descending aorta. In the thoracic region, it is referred to as descending thoracic aorta. Then in the abdominal region, it is referred to as descending abdominal aorta. Our terminal branch of abdominal aorta is our left and right common iliac. Then from our left and right common iliac, we have external and internal iliac and external iliac. We have internal and external iliac. Then from our internal iliac is where our umbilical artery will arise from. So this right here, our umbilical artery. So remember we have two internal iliac. So we have two umbilical artery arising from there. Don't mind my drawing is coming from the north to the west. However, this is basically the summary of our fetal circulation. Three shunts, our liver, which connect our left on left branch of portal vein directly with the IVC, and that's our ductus venosus. Then we have our lungs, which connect the pulmonary trunk with the arc of aorta, and that is our ductus arteriosus. And we have our foramen ovale, which connect the right atrium with the left atrium in the heart. And don't forget that the remnant of these structures. So our ductus venosum in adult life becomes our ligamentum venosum, our ductus arteriosus in adult life become ligamentum arteriosus, and finally our foramen ovale in adult life become fossa ovale, right? So this is basically it. Like, subscribe, and share.